I just see stuff, say stuff, run stuff, and copy-paste stuff, and it mostly works.
I mean, that really just captures the absolute chaos of the moment, doesn't it?
It really does. It's such a wild quote. And it comes directly from OpenAI co-founder Andrej Karpathy back in early 2025. He was describing his daily development workflow. I just see stuff, say stuff, run stuff, and copy-paste stuff.
Which is just, mind-bending when you consider who is saying it.
Exactly. Think about the weight of that. We're talking about one of the most brilliant minds in artificial intelligence, essentially declaring that the era of meticulously typing out brackets, managing memory allocation, handcrafting complex logic, that might just be over.
Yeah, completely over.
We've crossed this threshold where software development has fundamentally mutated. We're looking at a reality where traditional programming syntax is dying out and plain conversational English is the new primary programming language.
It represents a complete rewiring of the human-computer interface. We're no longer treating the machine as this dumb terminal waiting for explicit line-by-line instructions.
Right. And welcome to the deep dive. We are thrilled you could join us today. I'm your host, and joined as always by our resident expert. And the topic for this session is this massive paradigm shift known as vibe coding, or I guess in more formal circles, intent-driven development.
That's the one. Though vibe coding definitely caught on a lot faster.
It definitely did. So we've pulled together a massive stack of sources for you today. It's a mix of deep dive tech articles, industry research papers tracking these huge code repositories, and actual developer notes from the trenches.
Lots of really fascinating raw data in there.
Yeah, totally. So our mission for this deep dive is to figure out if traditional programming is officially obsolete. How does this massive shift impact anyone out there who's looking to build a digital product? And critically, what hidden risks are lurking in this new, ultra-fast era of software creation?
Right, because there are always risks. But let's ground this with a clear definition before we get too deep into the weeds. Vibe coding is basically an AI-assisted development method where instead of writing out the logic in Python or JavaScript or whatever, you describe your objectives in conversational language.
Just plain English.
Exactly. Then, these AI agents tools like GitHub Copilot, Cursor, or Anthropic's Claude Code, they ingest that plain English prompt and just generate the functional underlying code for you. It became so culturally pervasive across the tech industry that vibe coding actually won Collins Dictionary's Word of the Year in 2025.
Okay, let's unpack this, because to really understand why vibe coding feels like we've suddenly unlocked, literal magic, we have to look at the history of abstraction. The tech industry has always been on this trajectory, right? Moving away from telling a computer the how and getting closer to just demanding the what.
Yeah, there's a very clear lineage here. Every major leap in computer science has basically been about adding another layer of abstraction just to reduce the cognitive load on the developer.
So they don't have to think about the tiny details.
Right. I mean, we moved from writing raw machine code with literal punch cards to assemble a language, then up to high-level languages like C and Fortran, and eventually into these massive pre-built frameworks and object-oriented ecosystem.
And drag and drop visual builders, right?
Exactly. Each step basically meant the human developer had to worry less about the hardware constraints and could focus slightly more on the actual business logic.
It's a lot like the evolution of driving. We went from manually cranking the engine at the front of a Model T to driving a stick shift, where you still have to, feel the gears and match the RPMs, to an automatic transmission.
That's a good way to look at it.
But vibe coding isn't just an automatic transmission. It's like getting into the back seat, telling a self-driving car the destination, and just trusting the neural net to navigate the rush hour traffic for you.
Well, that car analogy works really well for the user experience, but I'd actually push back on it a bit when we look at the mechanics under the hood.
Oh, really? How so?
Because an automatic transmission, or even like a visual drag-and-drop IDE from 10 years ago, was entirely deterministic. You had fixed, predictable rules. You click a button, the exact same machine code is generated every single time. Modern large language models are completely different beasts.
Right, they're probabilistic.
Exactly. They are active, probabilistic participants. They aren't just following a strict rulebook.
They're guessing what comes next.
Precisely. When you vibe code, you aren't just pulling levers on a highly abstracted tool. You're essentially collaborating with a brilliant but completely unvetted intern who has read every piece of code on the internet but lacks any real-world common sense.
That is a terrifying intern.
It really is. And this shifts the human's role entirely.
Yeah.
You transition from being a syntax wrangler to an AI conductor. You're managing the output of a statistical engine rather than executing the logic yourself.
And if we're just sitting in the back seat giving directions to this intern, it means anyone who can articulate a problem can now drive the car. Which brings us directly to the massive socioeconomic shift driving vibe coding, which is democratization.
Yeah, the lowering of the barrier to entry.
The statistics in our sources are just staggering. We aren't just talking about spinning up a simple static landing page anymore. We have a documented case of a non-technical founder who built a fully functioning AI application, complete with complex state management and multiple external API integrations, in 4 hours.
Just 4 hours. That used to take weeks.
Weeks or months. And another completely non-technical team generated software valued at $35,000 in a single afternoon.
The velocity is just what's catching the legacy industry completely off guard.
Mhm.
If you want a clear barometer for how this is restructuring the startup ecosystem, you just have to look at Y Combinator's data.
Oh yeah, the winter 2025 batch.
Right. In their winter 2025 batch, 25% of the startups reported that 95% of their entire code base was generated by AI.
That is wild. A quarter of the batch barely even touched a keyboard for actual coding.
Exactly. And these aren't simple CRU'd apps. One health tech startup in that specific batch built a HIPAA-compliant patient portal in just 48 hours.
Wait, a HIPAA-compliant portal in 2 days?
2 days. We're talking about a system that has to adhere to strict healthcare data security regulations. It featured appointment scheduling, secure messaging, encrypted data dashboards, and they started with a single prompt: create a doctor-patient dashboard.
That's just unbelievable.
YC's Garry Tan actually went on record saying that 10 engineers today are delivering what used to take 50 to 100 engineers just a few years ago.
So let me play devil's advocate here. If I'm a marketer or a designer or a healthcare professional listening to this right now, and I have a brilliant idea for an app, can I really just log on to a platform like Lovable or Bolt, type in my idea, and build a 7-figure business without knowing what a for loop is or how to configure a database?
What's fascinating here is that, yes, we're seeing the barrier to entry lower entirely to natural language. The primary constraint is no longer your ability to write a for loop. The constraint is your domain expertise.
Meaning your actual knowledge of the industry you're building for.
Right. Think about a veteran nurse who knows exactly where the friction points are in a patient intake workflow. Historically, that nurse would have to find a technical co-founder, raise capital, and spend 6 months translating their specialized healthcare knowledge into technical requirement documents for a dev team.
So much friction.
Tons of it. Today, they bypass that translation layer entirely. They just describe the workflow to the AI agent, and the agent builds the tool.
It sounds like an absolute gold rush for creators and domain experts, but moving at lightning speed usually implies you're leaving a trail of wreckage behind you. If you don't know how the engine works, what happens when it stalls out on the highway at 70 miles per hour?
Well, this is where the narrative gets significantly darker. The exact same probabilistic nature that allows an LLM to generate a HIPAA portal in 2 days also introduces profound, invisible risks.
Yeah, the sources refer to this as the illusion of productivity, or the vibe coding hangover. Sure, your prototype works flawlessly on your local machine today. You demo it, the investors are amazed, but will it completely crumble tomorrow when 10,000 concurrent users hit the database?
And the empirical data on the flaws of vibe coding should give anyone pause. Researchers recently conducted this massive study analyzing over 300,000 AI-authored commits across public GitHub repositories. The findings were pretty brutal.
How bad are we talking?
The AI introduced 484,606 distinct problems into those code bases.
Almost 500,000 individual issues.
Yes, 500,000. And the critical detail is the nature of those issues. 89.1% of them were classified as code smells.
Code smells, so not outright errors, but...
Right. For those deeply familiar with system architecture, a code smell isn't necessarily a syntax error that crashes the compiler immediately. It's a subtle structural flaw.
Like what? Give us an example.
It's things like overly broad exception handling, massive cyclomatic complexity, or convoluted dependency chains. The code runs, but it's fundamentally rotten on the inside.
But why does the AI do that, though? I mean, if it's trained on all the best code in the world, why is it writing structural garbage?
Because of how large language models function at their core. They don't, quote-unquote, understand the logical constraints of the system they are building. They are predicting tokens. They are incredibly sophisticated autocomplete engines.
Right.
So if an LLM is trying to solve a problem and the statistically most common solution in its training data is a messy, hacky workaround from a 10-year-old Stack Overflow post, It will confidently generate that messy workaround.
It's mimicking the average developer, not necessarily the best developer.
Exactly. And the problem compounds when you look at security. That same study found that AI co-authored code had 2.7 times more security vulnerabilities than code written purely by humans.
2.7 times, wow.
And perhaps most alarming of all, 24.2% of the issues introduced by AI remained completely unfixed in the production environment.
Okay, let me push back on the panic for a second. When early drag-and-drop website builders or bloated web frameworks first hit the market, veteran developers complained endlessly about how messy the generated code was.
Oh, absolutely. They hated it.
They called it impure and said it would break the web, but those tools revolutionized the internet and the servers didn't catch fire. Why is the messiness of vibe coding any different from the messiness of old visual builders?
It's a common comparison, but it misses a fundamental difference in the failure modes. We're dealing with invisible fragility now.
Invisible fragility.
Yeah. A drag-and-drop tool might output horribly inefficient HTML, but it was a deterministic box. It generated the same messy code every time. AI, because it's a probabilistic black box, it hallucinates logic. It stitches together functions that look perfectly valid to the human eye, but contain catastrophic logical gaps.
Right, because it reads like clean code. It's formatted nicely.
Exactly. Take the platform Lovable, which is one of the premier tools for non-technical founders to vibe code apps. During a mid-2025 security review, researchers found that roughly 10% of the applications generated by the platform were actively exposing sensitive user data.
10%, that is a huge liability.
It is. And this isn't just an amateur problem either. Let's look at the Microsoft incident from the sources. A SQL injection vulnerability, which is a textbook catastrophic security flaw, was generated by GitHub Copilot.
Okay.
It was merged into Microsoft's own internal data formulator repository, and it sat there completely undetected for weeks.
Wait, Microsoft's own AI introduced a critical vulnerability into Microsoft's own code base, and a team of Microsoft engineers didn't catch it.
They didn't catch it, because reviewing AI-generated code is mentally exhausting.
Right.
When an engineer writes code, they commit a few files at a time. The logic is scoped. When you vibe code, the AI might generate or alter 40 files in 10 seconds. Reviewing that avalanche of machine-generated text is incredibly difficult, which leads to a massive loss of debugging intuition.
Debugging intuition. Let's dig into that, because I think that's a huge point for our listeners.
Sure. Think about how a senior engineer finds a bug. They have a mental model of the entire system. They understand the low-level behavior, so when a state management issue pops up, their intuition guides them to the specific module causing the race condition.
Because they built it.
Right. But when an LLM writes your entire application, you don't have that mental model. You are a tourist in your own code base.
A tourist. I love that. And LLMs are notoriously bad at maintaining context across massive projects, right?
Very bad. They have finite context windows. So if your app state is managed across 50 different components, the AI starts losing the thread. Yeah. One developer in our sources noted an incredibly frustrating experience.
Oh, the routing bug story.
Yeah. They spent 3 hours vibe coding an app that looked beautiful on the front end. Then they found a minor routing bug. They asked the AI to fix it and spent the next 15 hours trying to untangle the redundant checks, dead branches, and circular logic the AI had secretly woven into the back end just to patch that single bug.
So the non-technical founder is completely helpless in that scenario. They know how to prompt for the feature, but they don't know the language required to surgically repair the AI's hallucinations.
Exactly. They hit a brick wall.
So if the code being pumped out at hyperspeed is riddled with subtle bugs, security flaws, and structural code smells, then the industry fundamentally doesn't need people to write more code. It needs people who can act as an immune system against the AI's mistakes.
Which is completely rewiring the job market.
It really is. For anyone building a career in tech right now, the statistics for newcomers are brutal. Programmer employment dropped by 27.5% between 2023 and 2025.
And tech internships fell by 30%.
Right. The traditional gateway into the ecosystem is closing. The entry-level coder whose primary skill is writing boilerplate loops, setting up basic API endpoints, and typing out standard functions, that job is functionally gone.
The machine does the boilerplate instantly. So the traditional technical interview where you put a junior developer at a whiteboard and ask them to invert a binary tree or write a sorting algorithm from memory is completely obsolete. You're testing for a skill that a $20 a month subscription handles perfectly.
Here's where it gets really interesting. Hiring managers are completely tossing out that old playbook. They do not care how fast you can type out a React component. They are now actively testing for something they call engineering judgment.
Engineering judgment.
Yeah. Instead of asking you to write code, they will hand you a messy 500-line module generated by an LLM and say, the AI built this microservice, find the hidden race conditions, identify the security holes, tell us why this architectural pattern is going to cause a massive bottleneck when we scale to 1 million users.
If we connect this to the bigger picture, you can see a severe polarization happening in the talent pool. The floor is falling out for junior typists, but the ceiling is skyrocketing for veterans. Job postings asking for senior software architecture plus prompt engineering skills are surging right now.
The whole identity of the developer is shifting.
Yes. You are no longer a manual builder. You are an AI integration lead or a code quality guardian.
I saw one article refer to the new role as a vibe coding cleanup specialist. It sounds a bit ridiculous, but it's incredibly accurate.
It perfectly describes the immediate future. Companies need individuals with a rock-solid foundation in computer science who can look at the black box outcome, audit it for those 484,000 potential code smells, secure it, and integrate it safely into a massive legacy enterprise system.
So looking down the road, where does this leave the industry in the next 5 to 10 years? Are we entirely handing the keys over to the neural networks, or is there a sustainable middle ground that doesn't involve, constant security breaches?
The consensus across the research is that the chaotic, pure prompt style of vibe coding where you just type build me an app and cross your fingers is going to stick around, but it will be quarantined.
Quarantined to certain areas.
Right. It will absolutely dominate the indie hacking space, internal company tools, and rapid prototyping. It's simply too fast and too cheap to ignore for low-stakes environments.
But for the mission-critical systems, like banking infrastructure, healthcare records, aviation software, you can't just vibe code a plane's navigation system.
Exactly. For those domains, the industry is rapidly moving toward a paradigm called Spec-Driven Development, or SDD. Some engineers are branding it vibe engineering.
Okay, break down spec-driven development for us. How is that mechanically different from just writing a really detailed prompt?
It comes back to constraints. In pure vibe coding, the AI decides the architecture on the fly. In spec-driven development, human engineers spend their time writing strict, mathematically verifiable architectural rules, behavioral constraints, and security guardrails.
So they build the box.
Yes. You define the exact parameters of the sandbox using formal specification languages. You dictate how data is allowed to flow, what the memory limits are, and the exact API contracts. Only after the physics of that sandbox are locked down do you unleash the AI to generate the implementation code within those strict boundaries.
So the human defines the laws of physics, and the AI is just the construction crew building the house inside that universe.
Exactly. You get the incredible velocity of AI token generation, but it's physically bottlenecked by the rigor of traditional engineering discipline. The AI literally cannot generate a SQL injection because the specification layer prevents that type of database query from ever compiling.
So what does this all mean? If you're a seasoned software engineer, a bootcamp grad, or a domain expert with a startup dream listening to this, the core takeaway from all these sources is this. Do not abandon your technical fundamentals. The syntax might be dying, but the logic is more critical than ever.
Absolutely.
If 10 engineers equipped with AI can truly do the work of 100, you desperately need to be one of those 10. You have to be the person who deeply understands system architecture, who has honed that debugging intuition over years, and who knows exactly how to spot a race condition buried in a mountain of machine-generated text. You must leverage these tools to multiply your impact, but you have to keep your hands hovering over the brakes.
This raises an important question, however, about the ultimate trajectory of human-computer interaction.
Right, and this is the thought we want to leave you with today. Throughout this deep dive, we've discussed how plain English is becoming the new programming language. But as these models become exponentially more sophisticated, they are starting to communicate directly with each other to solve complex problems, utilizing their own dense, highly compressed, latent representations.
Basically speaking their own language.
Exactly. We might soon reach a horizon where human language itself, with all of its poetry, its ambiguity, and its fundamental imprecision, is simply too slow and too sloppy to act as the prompt for these massive systems.
Which is a wild thought.
It is. If the AI eventually learns to define the system's intent, the architectural specs, and the code structure far better than we could ever articulate it in a conversational English prompt, what exactly will the human's role be in the software of tomorrow? Will we just see stuff, say stuff, and hope the machine still cares enough to listen?
Definitely something to think about.
Something for you to mull over as you navigate this new era. Thanks for joining us on this deep dive.